So over the last few days, we've learned a variety of methods that we can use to solve systems of equations. What I'd like to do in this video is just go over these three options one more time. You'll notice that in problem 1, in problem 2, and in problem 3, we have the exact same starting equation every time. All I'm going to do is show you that these three options are ways of getting to the same answer three different ways. So we're going to start by solving this problem by graphing. I know that in order to solve by graphing, what I'm really looking for is where the lines intersect. So let's start by getting the y by itself so I can actually make these graphs. The first equation is x minus y equals 2. So I'm going to subtract the x on both sides, and I'm going to get negative y equals negative x plus 2. Now I'm going to divide by negative 1 to every single term, and I get y equals positive x minus 2. This line would start at the negative 2 and go up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1. Now when I draw this line, it would look like this. For the second equation, I also need to get the y by itself. So x plus y equals 4. I would just subtract the x on both sides, so y equals negative x plus 4. Now I'm going to start at the positive 4 and go down 1 over 1, down 1 over 1. And I notice that one of the points that I graphed landed directly on top of a point for the purple line. So this point right here is the answer I was looking for, which means the answer would be 3, 1. Now let's solve this exact same problem but using substitution. I know that to use substitution, I'm going to be plugging something in. So in order to do that, I need one of the variables to be by itself. In the first equation, I notice that the coefficient of the x is a 1, which means that's a good equation to rearrange. I'm going to add the y on both sides, and I'm going to get x equals y plus 2. Now I'm going to take this equation, I'm going to find the x in the other equation, and I'm going to replace that x with y plus 2. So I'm going to have y plus 2 plus y equals 4. Now y plus 2, there's nothing to distribute, so I'm just going to get rid of the parentheses and drop it down. Y plus another y makes 2y plus 2 equals 4. I'm going to subtract the 2 on both sides, so 2y equals 2, and I'm going to divide by 2 on both sides, so y equals 1. Now I'm going to take this number 1, I'm going to plug it into the original equation, and I'm going to solve to get x. So I'm going to have x minus, and instead of the y, I'm going to have 1 equals 2. To get the x by itself, I would add 1 on both sides, so x equals 3, which means my answer would be 3, 1. Now you'll notice that that is the same answer we got by graphing. So we found the place where the lines intersect, but we didn't graph it to do that. We just found it using substitution. Lastly, we're going to solve using elimination. Elimination means make one of the variables cancel. So if I look at these equations, I'm in luck because it looks like the y's are already ready to cancel. So the negative y and the positive y will cancel, which means I get 2x equals 6, so x equals 3. Now if x is 3, I can just take this x, plug it into one of the original problems, and solve to get y. So I would have 3 minus y equals 2. Now if I subtract the 3, I get negative y equals negative 1. And then if I divide by negative 1, I get y equals 1. So again, my solution would be 3, 1, which you'll notice is the same as the first two answers we got. We found that same answer using a slightly different method. I hope this helps you see that these are 3 different approaches to solving the exact same problem. In the next few days, we're going to start discussing when each of these approaches would be the most appropriate. So when does it make sense to use which one? And we're going to start to make some decisions to make our lives easier. Thank you so much for watching and have a great afternoon. We will practice tomorrow.